Okay, so today we are going to talk about something called regression. The idea behind regression is that you are fitting a function to the data that you have so that you could be able to make an equation, so eventually you could either set something, plug something into that equation and find a specific value, or set it equal to something and find a specific value. So let's begin with our do now. Okay, so our do now basically gives you data about bacteria growing in a petri dish. What we want to do is graph a couple of the data points and see if a linear function would best fit this model. Does a line best fit this model? So when I plot these points 0, 1, 1, 2, 2, 4, 3, 8, you can clearly see there's not some sort of constant slope. So I'm going to go ahead and say I don't think a linear model would be the best fit for this. Okay, no, because there's not a constant slope. What kind of function would be a better fit? Well, you might look at it and say, okay, that kind of looks like a parabola. So that is actually true. It does look like a parabola. Eventually, we're going to realize, though, that an exponential function is going to end up being the best fit for this situation. So you might be wondering, how do I know that? It's based on the growth factor. If I take a look at, what do I multiply to get from 1 to 2? I'm timesing by 2. What do I multiply by to get from 2 to 4? I'm timesing by 2. What do I multiply by to get from 4 to 8? I'm timesing by 2. The fact that I'm constantly multiplying by the same thing over and over, that's what tells me that this is an exponential relationship. This times 2 is actually the growth factor in this particular situation. That's the growth factor. That's that 1 plus b thing that we've referred to before. And the fact that that's bigger than 1, that tells us that it's growth. It also makes sense because when you look at the equation, it is actually increasing as we go along. Okay, so the good thing is most of the time doing a regression equation, you're not going to actually have to do the regression yourself. What you're going to do is plug the data in the calculator and figure out what the equation would be from the calculator. So let's skip ahead to the calculator notes here. So unfortunately, I can't cast my graphing calculator while I go through this. So I'm going to make sure I explain to you the directions. Feel free to pause the video at any point and rewind if you missed something. So what we're going to do is you're going to go on your graphing calculator and you're going to start by hitting the stat button. Okay? After you hit the stat button, hit enter on number 1 edit. Okay? For a calculator to give you an equation for data, you have to enter the data into your calculator. So there's going to be 2 rows of information, a lot of times a row of x's and a row of y's, that you're going to enter into the column called L1 and L2. You always want it to be so that your x's are L1 and your y's are L2, or another way to think of it is your inputs are L1 and your outputs are L2. After you've entered your data into L1 and L2, and make sure that you've lined up and said, okay, if there's 5 elements in L1, there has to be 5 elements in L2. If they're not the same, you're going to get an error when you actually try to go through the next process. After you've entered your data, you're going to hit second quit and go back to your normal calculation screen. Okay, so you've now entered your stat information in. Now you have to use the built-in stat functions. So once again, after you've entered L1 and L2, you're going to go back and hit the stat button again. You're going to scroll to the right and you're going to go to the calc menu. And you're going to select a regression based on the information, based on what you were provided with. So there were other kinds of regressions you may have gone over earlier in the year. The 2 I would say that are probably the most important for you to know are linear regression and exponential regression. Fitting a line to our curve or fitting an actual exponential curve to our curve. So after you hit that stat, move to the right to the calc menu, you'll see number 4 is a linear regression. Okay, you'll notice it says AX plus B. That's a lot like MX plus B, so hopefully that makes sense. You're fitting a line to the data you've input. Or if you scroll down further to 0, you can see exponential regression. That's what we're going to be using for today, is exponential regression. Okay, so after you've hit a 0 on EXPReg, you make sure it says L1, L2, and you hit enter and calculate, and you should end up seeing an output that looks something like this. Okay, it says EXPReg. What's nice is it gives you what is the model of the equation you're plugging into. So y equals AB to the x. What is the x value, the a value to plug in for that a? And you can see right here, it's 1.240. And then if you want to do the b value, you can see that that comes out to be 2.426. So eventually when I input that a and b value, that's how I end up with this equation over here on the left. 1.240 2.426 raised to the x. I would say for today, try to round everything to 3 decimals. So here's what you're going to do with this equation now. One thing might be, is this exponential growth or decay? So if you take a look at our growth factor, the base of our exponential expression, our growth factor is 2.426. Because of the fact that our growth factor is bigger than 1, that tells us that this is growth. Okay, remember, if that growth factor is less than 1, that would be decay. Now, what else are you going to do with this equation? Either somebody's going to give you an x to plug into this so that you could solve for y, or you're going to plug in a number for y and use some sort of, equation solving method to solve for your x value. So let's begin with question number 1. It says the table below shows the concentration of ozone in the Earth's atmosphere at different altitudes. Okay, you're writing an exponential growth equation to represent this model, or regression equation, not growth. You'll see it as a growth, but yeah, we'll get there. All right, so the first thing we need to do is we need to enter our data into the calculator. Okay, so remember, you're going to have a list of x's, which you're going to call L1, and a list of y's, which you're going to call L2. So you're going to go to your calculator, you're going to hit Stat, number 1, Edit, and you're going to enter in these data into L1, and then you're going to go to the right and enter in these data into L2. Okay. Now, once you've entered your data in, you're going to quit out of that Stat menu and go back to your normal calculation screen. Then you're going to hit the Stat button again, go to Calc, and scroll down to 0, EXPReg. That's an exponential regression. So you're going to see an output similar to what we saw up here on the right-hand side before. It's going to give you the model of the equation as y equals ab to the x. It's going to give you the a, it's going to give you the b, and you're going to round to the nearest thousandth, so 3 decimal places. The equation you should be getting is y equals 0.488, 1.116 to the x. So what are you going to now do that you have this equation, this regression model? Well, you're going to do one of two things. You're going to plug into it, or you're going to set it equal to something. So look at part B. Based on the model you created in part A, determine what the ozone units would be when the altitude is 50. If you look right here, the altitude is x. So this is basically saying take the equation you created and plug in x equals 50. So I have y equals 0.488. 1.116 raised to the 50. I'm plugging 50 in for x. And that comes out to be 117.931. Okay, for today, like I said, let's just round to 3 decimals, although usually that will be, more specified as we go along. So that's probably the easy way to use our regression equation. It's a little trickier when you have to actually set it equal to something and solve. So take a look at letter C. Determine the altitude when the ozone units will be 7.8. Okay, so the ozone units this time are 7.8. Our ozone units are our y. So this says take our regression equation and plug in y equals 7.8. So I have 7.8 equals our whole regression equation we made before, 0.488, 1.116 to the x. So you'll notice that this is an exponential equation. How do we solve exponential equations, especially when you can't get both sides to have the same base? Well, what you're going to do is you're going to use logarithms. So I can't just ln or log each side just yet because of this 0.488 that's in the front of the 1.116 to the x. If you remember, when you're solving an exponential equation, you have to isolate the exponential term first. So what I'm going to do is I'm going to divide both sides by 0.488. Okay, as I do that, I'm going to get something like 15.98361. I would say since it's the middle of your problem, keep at least 5 decimals. That way you guarantee that the last part of, when you round at the end, will be as accurate as possible. Or you could actually leave it as 7.8 over 0.488. Up to you. On the right-hand side, I have 1.116 to the x. And now this is when I can bring in those logarithms. You can use the log on both sides or ln on both sides. It's honestly up to you. I tend to use ln, but it literally does not make a difference. So I'm going to make the left-hand side ln of 15.98361, and then the right-hand side ln of 1.116 to the x. This is where our log properties come in to be very helpful. If you have an exponent of something inside your logarithm, you can drop that exponent down in front. Okay, so you can now rewrite this as ln of 15.98361 equals x times the ln of 1.116. And now all I have to do is divide by ln of 1.116 to get the x by itself. So I'll end up taking ln of 15.98361, dividing it by ln of 1.116. And in this case, like I said, since it doesn't specify, we'll keep 3 decimal places. We'll find out that x comes out to be 25.253 for x. There were no units given in this particular problem, but obviously watch out for units if that's given. And what that means is that for the ozone units to be 7.8, the altitude had to be 25.253. Okay, thanks for watching.